Welcome to the Deep Dive. We're the show engineered to give you that shortcut to being genuinely well-informed. Lots of surprising facts, hopefully just enough humor to keep it interesting. Today, we're heading out there. A deep dive into Beyond Earth. Seriously, we're talking about how humanity isn't just, dreaming of space anymore. It's happening. It's unfolding right now. And wow, this past week saw some incredible breakthroughs. So our mission today, it's pretty straightforward. Our amazing research team compiled just a mountain of sources, articles, papers, notes, you name it. And we're digging through it all to pull out the really crucial stuff, the mind-bending facts. Think of this as your fast track, yeah? Your express lane to understanding what's next in space without having to read all those dense reports yourself.
And what's really striking, looking at what the team pulled together, is the consensus. You see the same themes popping up across different reports. These aren't just random events. They really signal a pivotal moment. So our focus isn't just what happened, but kind of why it matters, the tech, the strategies that are fundamentally reshaping, well, the whole space economy. It feels like a foundational shift, almost like, the early internet, but way bigger, spatially speaking.
Okay, let's blast off then. The reusable rocket race.
Yeah.
It's not just warming up, it is absolutely on fire. And we saw some really fascinating, almost kind of contradictory things this week. And look, if you thought this race was just between, the usual big games, get ready for a curveball. The biggest surprise, well, for me anyway, it's got to be Honda.
Well,
Honda. Entering the space race and how they did it. Yeah, picture this. Honda, the company we know for, like precision cars, robots. They just launched an experimental rocket. Tiny test flight, barely a minute long, right? 56.6 seconds. This thing, 6.3 meters tall, goes up 271 meters. And lands, get this, 37 centimeters from its target.
Yeah.
37 centimeters. That's absurdly precise.
It really is surgical.
Exactly. It wasn't some huge, flashy launch, but it showed this incredible world-class precision. It tells you this major industrial player is leveraging all that expertise they already have and diving right into space. And they're aiming for suborbital flights by 2029. Makes you really wonder what else they're working on, doesn't it?
It does, and the contrast is just so striking with SpaceX. While Honda is celebrating this pinpoint landing, our research flagged that significant setback for Starship, Ship 36, the upper stage, exploding during a static fire test.
Right. An explosion sounds bad. Really
Yep.
bad.
Well, yeah, objectively it is. But, for SpaceX, it's almost baked into their process, that whole fail fast, learn fast, iterative approach. But what's interesting this time, according to the analysis, is that the failure points towards, well, not flight dynamics, but manufacturing reliability, component quality control.
Ah, okay. So it's shifted.
Exactly. It's moving from, can we make this thing fly, to can we build hundreds of these perfectly reliably? And that's a critical transition, especially for programs like NASA's Artemis. They're counting on Starship for the moon landings, right?
So yeah, Honda's showing this small-scale surgical precision, and SpaceX, the current king of reuse, grappling with mass production challenges at this massive scale, really shows that there are maturity levels here. But what about Europe? They're often seen as maybe a step behind in reusability. How are they responding? Are they really in this race or just trying to catch up?
Oh, they are absolutely not just standing by. Look at France's space agency, CNES. They're leading the Aestri reusable engine project. They're working with partners, Pangea, Ariane Group, on a really high-performance engine. It uses full-flow staged combustion. That's the same advanced, super-efficient tech SpaceX uses in their Raptors.
Okay, full flow staged. Sounds complicated. Why is that specific tech so important?
Well, without getting too deep into the rocket science weeds, basically, it burns everything super efficiently before it even gets to the main chamber. It gives you enormous power and efficiency. They're targeting, 2,000 to 3,000 kilonewtons of thrust? That's huge.
Wow, that's a massive number.
Yeah.
But is it just about having a big, powerful engine, or is there a dopper strategy here for Europe, like autonomy?
Oh, definitely. If you zoom out, ASTR is absolutely critical for Europe. It's about closing a pretty significant technology gap, and securing their own way to space in an era that's going to be dominated by these fully reusable rockets. It's not just cool tech for tech's sake. It's strategic. It's a necessity. If Europe wants guaranteed access to space, commercially, defensively, they can't rely solely on others. It's about sovereignty, basically.
So, for you listening, what does all this competition, this global push for reusability, really mean? It's not just cheaper launches, though that's huge. It's fundamentally changing the economics of space. Imagine like a university lab launching a small satellite affordably every few months, or a startup testing new materials up there easily. It's democratizing space, bringing it down from just governments and billionaires to something much more accessible. It unlocks possibilities we probably haven't even thought of yet. Okay, so that's getting to space. cheaper, more options emerging. But what about once we're actually up there? This next bit. Wow, this really jumped out from the research. Our team flagged China's orbital servicing breakthrough. Incredible. This past week, their Shijian-21 and Shijian-25 satellites got really close up in geosynchronous orbit that's like 22,000 miles up, where satellites stay over one spot.
Yeah, way up there.
And they performed what looked like a refueling demonstration.
Yeah.
And here's the thing. It wasn't just, China saying they did it. Multiple independent companies confirmed it.
Right.
Even the U.S. Space Force observed it. It's like they pulled up to a gas station in orbit.
That's a perfect analogy, actually. And the significance is just immense. Think about it. We used to treat satellites like disposable cars. Run out of fuel. Tough luck, it's junk now. Orbital refueling could dramatically extend their lifespans. They become long-term infrastructure, not disposable assets, which, by the way, helps with space debris, right? Keep things working longer, less junk floating around. It makes space ops much more sustainable.
Makes total sense.
But, there's also the dual use aspect, the capability to get that close, maneuver that precisely, maybe transfer fluids. It's a powerful capability that has, let's say, strategic implications beyond just refueling. It's something everyone's watching closely.
Right. So sustainability, economics, and strategy.
Got it. Okay, moving beyond just servicing things. What about actually making stuff in space? Our research flagged a huge step here, too. The European Space Agency, ESA, they achieved the first European metal 3D printing in orbit on the ISNs. They actually fabricated a metal part up there. Now, game-changing gets thrown around a lot.
It does.
And yeah, printing one part sounds cool, but is it really game-changing yet? Or is it still just a tiny step? How far off is, industrial scale?
That's a fair question. Look, in terms of volume, yeah, it's a small step.
Right.
But the precedent it sets, the potential it unlocks, that's the game changer. Think about it like the Wright Flyer's first flight. Short hop, right? But it proved powered flight was possible. This proves we can make complex parts, tools, maybe even spares, on demand, in orbit. That hugely reduces the need for costly resupply missions from Earth. It boosts autonomy. It's laying the groundwork for actually living and working off-world sustainably. It's not about industrial scale today, maybe, but proving the capability for tomorrow. That's how these revolutions start. Okay, I see that. It's the proof of concept that shifts the thinking. And speaking of shifting things, another critical piece, maybe less flashy, came on the regulatory side. Vartis Space Industries got the first ever multi-mission FAA Reentry license. This lets them bring back multiple manufacturing capsules through 2029 without needing a separate license each time. Doesn't sound thrilling, maybe, but I bet it's huge.
Oh, it's absolutely huge. You called it legal technology earlier, and yeah, bureaucracy can be a technology, a crucial one. Think about Vartis plane, making high-value things like pharmaceutical crystals in microgravity. You can have the best orbital factory ever, but if you can't reliably and predictably get your product back to Earth legally, your business model is, grounded.
Right, dead on arrival or re-entry.
Exactly. So this multi-mission license gives them that regulatory certainty. It's like a VIP pass for their space-made goods. It de-risks the whole venture enormously and paves the way for a real, actual supply chain between orbit and Earth. Without this kind of boring but essential stuff, the commercial space economy just stays hypothetical.
The essential plumbing that makes the exciting stuff flow. Got it. And as we get more stuff happening up there, we need better ways to move around in space, right? Not just launch, but orbit to orbit. Enter the orbital tugs. Portal Space Systems Supernova is a great example highlighted in the research. It's this multi-role spacecraft, novel propulsion system, solar thermal, apparently offering a massive 6 kilometers per second of delta V.
Which is industry leading, yeah.
So delta V sounds technical, but basically it's like its total maneuvering fuel, its ability to change speed and direction, right?
Pretty much, yeah. Think of it as its total propulsive capability, how much oomph it has to change its orbit.
So 6 kilometers is a lot, meaning it can zip between orbits really efficiently, like a super fast, super efficient Uber for satellites. And Portal wants to build one per month by 2027. That sounds like serious scale.
Yeah, it is. And we see these tugs as this absolutely critical middle layer for space logistics. You need launchers to get you to the front door, LEO maybe, but these tugs, they take your package to the exact right room, the final orbit, whether that's GEO or lunar orbit or somewhere else entirely. They create that flexible, resilient, dynamic infrastructure within space, like a shipping network, but in 3 dimensions. It makes the whole system work better.
So, okay, let's connect the dots for everyone listening. You've got cheaper launches from reusability. You've got orbital servicing, keeping things alive longer. You've got making stuff in space. You've got the regulations smoothing the path back home.
And now these tugs moving things around efficiently. It's really clear this isn't just about astronauts anymore, is it? It's about building whole new economies, new capabilities beyond Earth. And that's going to ripple back and affect industries right here on the ground. New materials, new medicines, new comms. Ways we probably can't even predict yet. So where does this all lead in the long run? As we build this beyond Earth future, what are the foundational bits being laid now, and what are the big hurdles still in the way? Our research team looked at infrastructure, the ISS, the International Space Station. Amazing achievement, but let's be honest, it's getting old, right? There's that air leak in the Russian module Zvezda. It just caused the X-4 private mission to be postponed. Constant upkeep.
It really highlights a dual challenge. You've got to maintain this vital but aging infrastructure while you're also trying to build the next generation of platforms, ones that are maybe more resilient, more autonomous. And you see that with China's Tiangong station. It clearly benefits from lessons learned from the ISS over decades. They recently added more debris shielding. They're opening up to international partners. It seems designed with longevity, autonomy, expandability baked in from the start. It's just the natural evolution, really.
And holding a lot of this future together, there's this sort of silent revolution happening. Optical communications, like fiber optics, but for space. The reports project that market is going to explode. From around $3 billion now to over $10 billion by 2034. Why? Well, way higher bandwidth, faster speeds, lower latency, and better security than old-school radio waves. It's like upgrading the entire solar system from dial-up to fiber broadband.
Exactly. And that growth is tied directly to the absolute flood of data coming from all these new sensors in orbit. Satellites are gathering more images, more signals, more data than ever. Optical comms are vital just to get that data down, but it also drives the need for more processing on the satellite, onboard AI. Instead of just dumping raw data, the satellite can analyze it, find the important bits, and send down just the intelligence. Much faster, smarter, and quicker.
Makes sense. Get the insights faster. Now, all this progress, it's amazing. But the research also reminds us challenges remain. Big ones. Technical hurdles, like that Starship explosion, or Blue Origin still working on landing their new Glenn booster. It just reminds you, this stuff is hard. Pushing engineering boundaries isn't easy.
Not at all.
And then there's the regulatory friction. Like Varda had those initial reentry delays before getting the multi-emission license, it shows our ground-based systems, our rules, are still catching up to these new commercial space models. There's a learning curve everywhere.
And that brings us to maybe the biggest challenge, the one that worries a lot of people long-term: space debris, orbital traffic management. The ISS just had to dodge a piece of an old Chinese rocket from, 2005? And the reports say these close calls, these avoidance maneuvers, they're happening more often.
Yeah, it feels like that's becoming almost routine news now.
It does, and it's like having a highway with way more cars, faster cars, but no stoplights, no lines, no rules of the road. It really highlights how urgently we need better tracking, better policies, and crucially, international cooperation. We need to avoid that nightmare scenario, the Kessler syndrome, where one collision creates debris that causes more collisions in a cascade, potentially making key orbits unusable. It's a serious threat we need to tackle collectively.
Absolutely critical. Okay, so wrapping this up. This week's developments, taken together, they really underscore this truly transformative time for space. We're shifting gears, right?
Yeah.
From just reaching orbit to actively building, operating, commercializing in orbit beyond Earth.
Exactly. It's not just about flags and footprints anymore. It's about building real capability, real commerce off planet. And all these threads, the reusability, the in-space manufacturing and servicing, the better propulsion, like those tugs, the clearer regulations, it all points toward, a circular space economy starting to emerge. A future where what we can do and make in space becomes just as strategically important, maybe even more important than just being able to launch things there. It's about living and working in space sustainably.
So, as we finish this deep dive, here's something for you to think about. What does a future truly beyond Earth actually mean for us, for humanity? Is it about new resources, new ways of living, maybe even completely new global dynamics? And maybe more personally, how will you contribute to it, or how will it affect you? The questions are just as big as space itself, really something to mull over. Now, if you found this insightful, and we hope you did, please take just a second to like this video, subscribe here to the deep dive, and definitely hit that notification bell so you don't miss our future updates. And if you're listening on a service like Apple Podcasts or Spotify, we would be hugely grateful if you could leave us a quick rating and maybe a review. It honestly helps us reach more people like you. We really do love hearing what you think. So whether you're on YouTube or your podcast app, drop a comment. Let us know your thoughts on this deep dive into Beyond Earth. We'll see you next time.